Okay, let's jump straight in. What if the beauty you find in, say, a Shakespeare play, or maybe music by Bach,
Mhm.
what if it isn't just about the words or the notes themselves, but also about some kind of hidden mathematical structure underneath it all?
It's a really fascinating idea. I mean, it challenges that common assumption we have, right? That art and creativity are totally separate from, well, from the precise world of math and science.
Exactly. So for this deep dive, we've been looking into some insights from the mathematician Marcus du Sautoy, particularly his work on what some call Shakespeare's hidden math, and ideas from his book Blueprints.
Yeah, and our mission really is to unpack what these sources are suggesting about how mathematical thinking might actually be woven into creative works. It might surprise us, give us a different lens on familiar masterpieces, and maybe make us rethink that perceived split between disciplines.
Right. Think of it like searching for the underlying code, the unexpected blueprints hiding in plain sight within the art.
And then considering what that means for how we even categorize knowledge.
Okay, so let's start with Shakespeare. The writing itself, specifically the rhythm. Most of his plays use iambic pentameter, that familiar da-doom beat we all learned.
That's the bedrock, yeah. 10 syllables per line, alternating unstressed and stressed. It gives it that predictable flow, almost like a heartbeat or a metronome.
But here's where it gets really interesting, according to these sources. Shakespeare deliberately breaks that pattern.
Yes, and crucially, he seems to do it in ways that are numerically significant, often using lines with the prime number of syllables.
Like 11. The classic example always cited is from Hamlet. To be or not to be, that is the question. If you say it aloud, count the syllables. It's 11.
Uh-huh. And the point is, this isn't just, an accident or sloppiness. That shift away from the expected 10 syllables, especially to a prime like 11, it kind of jolts the listener. It breaks the rhythm you've settled into. It signals something important is happening, emotionally weighty, thematically crucial, makes you lean in.
It's a structural disruption, basically, that grabs your attention. And it's not just 11 syllables, is it? The sources point to another specific number used symbolically.
7, right, 7 syllables. This pattern seems to pop up often in moments connected to magic or the supernatural in the plays.
Yeah, like the witches in Macbeth. Or think about Puck in A Midsummer Night's Dream. A lot of their lines, where things get mystical or otherworldly, fall into that 7-syllable structure.
It's quite subtle, but it works. It helps create this unsettling or mystical feeling. The audience probably isn't sitting there counting syllables consciously, at least. But that different rhythm contributes to the feeling that something strange or powerful is unfolding. It adds the sort of numerical texture.
So that's the plays. But these numerical hints, they seem to appear in Shakespeare's sonnets too.
They do. The sources mention some really intriguing examples where the sonnets seem to echo numbers related to, well, time.
Like Sonnet 12,
Yeah.
which talks about time's destruction and specifically mentions a clock, 12 hours on a clock face.
Exactly. Or Sonnet 60, which is all about the relentless march of minutes, reflecting the 60 minutes in an hour.
And wasn't there one linked to the year?
Yes, Sonnet 52. The connection drawn is to the 52 weeks in a year.
Now, okay, these correlations aren't necessarily smoking gun proof that Shakespeare had a calculator next to his quill pen.
Right. It's suggestive rather than definitive.
But it does hint at a possible kind of numerological architecture, maybe an underlying structure tied to time, cycles within the sonnets. Makes you wonder, was it fully intentional, or did his creative intuition just naturally lean towards these resonant numbers?
And that leads to a wider point, really. This interplay between numbers and art. It's not just a Shakespeare thing. It's not some isolated quirk.
No, definitely not. Think about Bach, another giant. He famously used numbers symbolically in his music, too.
Oh, absolutely. He'd embed numerical codes based on letters into his compositions, like a musical signature. The famous one is using notes that correspond to BACH in the German system, which numerically adds up to 14. It was a way of sort of embedding his name right into the fabric of the music.
And what's really key here, I think, is the historical context. People like Shakespeare, like Bach,
Yeah.
they lived before everything got so specialized.
Exactly. Before the rigid academic silos we have now. The lines between what we call art and science were much, much blurrier back then.
It was an era where you could have real cross-pollination.
Yeah.
A Renaissance figure could be a painter, an engineer, maybe dabble in math and philosophy. Knowledge wasn't chopped up into neat little boxes.
Absolutely. Which connects nicely to a core argument from Marcus du Sautoy's book, Blueprints. He argues that mathematics, fundamentally, is the study of structure.
And structure is everywhere in art. You see it in symmetry in paintings, the rhythm in poetry, the form of a musical piece, the layout of a building. It's unavoidable.
So the sources make this compelling case that artists often stumble upon mathematical principles, not through formal study, but just through their creative exploration.
They're drawn to certain patterns, certain rhythms, proportions, because they feel right. They feel aesthetically powerful or pleasing. Their intuition guides them to these structures.
Structures that mathematicians later look at and say, ah, yes, that's fundamentally mathematical.
Which brings us to one of the, well, frankly, most surprising stories mentioned in the sources. One that really flips the script on how we usually think math discoveries happen.
You mean the Fibonacci numbers? We all learn about them, right? That sequence, 1, 1, 2, 3, 5, 8. Each number the sum of the two before it.
Yeah, and we usually credit Leonardo of Pisa, Fibonacci, with discovering them, or at least popularizing them in the West.
But the sources highlight that this sequence was actually known centuries before Fibonacci wrote about it in Europe.
Really? Who discovered it then?
Well, it seems the true discoverers were Indian poets and musicians, particularly tabla players, exploring rhythmic patterns. They were playing around with rhythms using long and short beats, like a 2-beat and a 1-beat sound. And they were figuring out how many different rhythmic sequences of a certain total length they could make. And in doing that, just by exploring rhythmic possibilities, they discovered the Fibonacci sequence.
Wow, so that's a perfect example of purely artistic, creative exploration leading directly to a pretty fundamental mathematical truth, not the other way around.
Exactly. It's why du Sautoy actually suggests maybe we should call them Hemachandra numbers after one of the Indian scholars who documented them much earlier. Give credit where it's due.
Fascinating. Okay, let's bring this idea into more modern times. The sources mention the 20th century composer Olivier Messiaen.
Ah, yes, Messiaen. His Quartet for the End of Time is an incredible piece written while he was actually a prisoner of war. And it's a powerful example of using explicit mathematical structure.
How so? What did he do?
Well, in one famous movement, he used a rhythmic cycle based on 17 notes, playing against a harmonic cycle of 29 chords or notes.
Okay, 17 and 29. What's special about those numbers?
They're both prime numbers.
Ah, and what does that do musically?
Because they're prime and they don't share any common factors, the two cycles, the rhythm and the harmony, take a very, very long time to come back into sync simultaneously. They sort of run independently alongside each other. This creates this amazing feeling of suspension, of timelessness, an ethereal, floating quality that fits the theme of the piece perfectly. It avoids regular, predictable repetition.
So the math directly creates the aesthetic effect he was after.
Precisely. And apparently, later mathematical analysis of some of his other works, his 12-tone pieces, found even deeper stuff. Using things like group theory, mathematicians found structures corresponding to really rare, complex types of symmetry things called sporadic simple groups, existing in high dimensions.
Wow. Okay, so even if Messiaen wasn't thinking, I'm going to map this onto a sporadic simple group, his intuitive musical choices aligned with these deep mathematical structures.
It seems so, which underscores this whole idea intuitive aesthetic decisions can resonate with profound mathematical truths, whether the artist is consciously aware of the underlying math or not.
Okay, so let's try and synthesize this. Looking back at everything from Shakespeare's rhythms and sonnets, Bach's codes, those ancient Indian rhythmic discoveries, Messiaen's primes, what are the big takeaways from these sources?
Well, one key point is that this connection manifests in different ways, doesn't it? Sometimes it seems quite intentional, like Bach maybe coding his name, or perhaps Shakespeare with some of those time-related numbers in the sonnets.
Right, a conscious embedding of pattern.
But then other times, it feels much more intuitive. Artists are just drawn to structures that feel aesthetically right, that work creatively. And only later do we, or mathematicians, recognize the deep mathematical significance. Like the Indian musicians finding the Hemachandra numbers, or Messiaen's use of primes creating that timeless feel.
And this whole exploration, it really does challenge that rigid boundary we tend to draw, especially today, between the humanities and the sciences, the two cultures idea.
Absolutely. It suggests that maybe the most fertile ground for really deep creativity, for breakthroughs, is actually right there at the intersection, where the logical elegance of structure meets the expressive power of intuition and, well, imagination.
Yeah, it makes a strong case for a more integrated view of knowledge. Du Sautoy calls it a Renaissance-like blending of disciplines, trying to recapture some of that interconnected worldview.
Moving away from the fragmentation that maybe specialization has led to.
It's a really powerful thread, isn't it? This hidden strand of mathematical structure running through things we often think of as purely artistic.
Hmm.
It's there in the rhythm of a line, the form of a sonnet, the patterns of beats, the cycles of notes. And these sources argue they weren't just, happy accidents.
No. They seem to be either deliberate choices or these deep intuitive pulls towards structures that happen to resonate with fundamental mathematical principles.
Which really makes you wonder about the world around you, doesn't it?
Hmm.
So maybe here's a final thought, a provocative one for you, the listener, to take away from this deep dive. If structure is a fundamental language that mathematics uses to describe the universe, and we find that exact same language, structure, is inherent and essential in so much human creativity in art, music, poetry, well, where else might you start noticing these unexpected blueprints showing up in the world?
Yeah, it's an encouragement perhaps to look for those surprising connections yourself, to sort of bridge those seemingly separate areas of knowledge with your own curiosity. See what you find.